Okay, so tonight we are going to cover recursion, which is basically chapter 15. We had to make a little adjustment from last week since we were not able to cover chapter 14. So recursion is both in this book, the watermelon book, and it's also in the data structures book as well. Um, but recursion it's really different in that um, it it's like looping, but it's kind of like those Russian wooden dolls where you take one apart, there's a smaller one, you take it apart, there's a smaller one, you take one apart, there's a smaller one. It's kind of like that because, as you'll see here in just a few minutes, it really it's kind of different, like I said, because it's a method that calls itself. Ooh, how does that happen? Okay, so if we take a look at the very first page of the book, it's got this endless recursion.java. If we take a look at it in Eclipse, we can see that here we've got my class endless recursion, and I've got a method which is called message. It's a public static void message, and in here it basically says print this is a recursive method, and then it calls message. So just like the name of the class says, it's endless. So if we run this guy, what's going to happen? Um, ah, I probably need... Okay, so if I have a driver where, in this case, it's called recursion demo, and it's a public static void main, and there I say endless recursion. So again, we're looking at this guy. It just basically says system print, this is a recursive method, and then it calls itself. Okay, so if I run this guy, what's going to happen? When I run it, you'll see that we get an error because it says, hey, at some point, I went past the numeric value amount that I can basically handle. For example, as we know, shorts have the highest number you can go is 32,768. Well, this is one of those cases where it went beyond the number that it could basically handle. So again, it was an endless recursive, and it kept calling itself and display, call itself and display, and call itself and display, and call itself and display. So that's basically where the problem lies. So with recursion, we have to make sure that we have a way out, just like any loop. So this is kind of like a loop, but it's kind of not like a loop. So what I want you to think of it is think of it every time that it calls itself, it calls the other method, the first method is still there. So it basically created another one, and created another one, and created another one. So it kind of keeps staircasing down and staircasing down and staircasing down. Now, let's go back to this endless recursion. So right here, it calls itself, so it comes back up and calls message again. Now realize it has not hit that ending brace yet. It has to hit that ending brace to end the run of that method. So that first method is still running. It calls itself again, so it creates basically another object of that method running, and then it calls itself again. So again, it never hits that ending brace. So I want you to understand that. So it keeps creating a new image of that particular method. It calls itself again, creates a new one, creates a new one, creates a new one, creates a new one. It keeps doing that. And again, at some point, it needs to hit each one of those items that it basically calls. So each one of those methods that it calls, it really needs to end that method. So if we take a look at let's see what the book shows here. So we've got this thing called recursive. So if we take a look at recursive, here it basically says it's the same exact thing, except this time we've got an int that we are passing it. So it's bringing in an int. So it says if int is greater than 0, then we're going to say this is a recursive method. And then we say message n minus 1. So we call itself again. So again, think of a new message method being created and called, and this time we're passing in the variable n, but it's subtracted by 1. We call it, it does that, it calls itself again with a lower number and a lower number and a lower number and a lower number. And when that variable gets to 0 and that particular item is right here, it will hit this 0 and it will hit this ending item, and then we'll go back to the calling method, which n is not greater than 0 because it's 0 again, and it drops out. It drops out and it keeps dropping out and it keeps dropping out of the method that called itself. Okay, so think of the method calling itself. It says create a new method. It's identical. It calls it, and then when it calls itself again, it creates a new one, creates a new one, creates a new one. But each one of those are stair-stepped, and they do have to get back to this particular item, which then gets to this item, and it basically keeps ending each method altogether. Okay. So if we run this guy, rename this to recursive, and we'll put a 5 in here. Let's put a 5 in here. Okay, so it's expecting, because again, in this guy, it's expecting an int to be passed to it. So this time we run it. This is recursive 1, 2, 3, 4, 5. So it happened 5 times. So if it was a loop, it would make a whole lot of sense to me, but this is recursive, so it's really kind of hard to understand. So here's what I'm going to do. Well, let me do it this way. So think of it this way. It calls message the first time, and that's got a 5 in there, okay? Which then it calls message again. Let's go back to demo. So the very first time this is called, it's got a 5 in n. So n is equal to 5. Okay. Then it says if n is greater than 0, and it is, it's going to say display the message, so it displays this is a recursive message. Then it calls itself, but it takes n minus 1, so it calls message again, and n is now equal to 4. Okay, so this is calling message, this is calling message again, but with the number 4. We display that message, and then we call message again, except n minus 1, so n is now equal to 3. We basically then stair step down again. So each one of these flat pieces is it calling message. And again, realize we have not hit this ending brace yet. So then we display recursive method. We call message again, so it basically calls itself, but we subtract 1 from it. So n is now equal to 2. We call message again. So now we've got it going. So just think of it this way. Think of message. The message method is now open in 4 different rooms. Okay? And each one's calling itself. So then we call it. We display this is a recursive method. We pass n minus 1, which n is now equal to 1. And again, we call message again. We come back around. We say this is a recursive method, which is n minus 1, which is now n is equal to 0. Now this n can be seen by every single one of those method message methods. They all see the same variable n. So that's the one thing that's common to all of them, is the variable that's being passed. So now, so displayed that 1, 2, 3, 4, 5 times. Then it comes in and basically it calls message, which comes back around and says if n is greater than 0 and it's not, it hits that guy. And then it basically hits that guy, which gets out of this one, and it comes back around to the method that called with 1, and it says if n is greater than 0 and it's not, because it's equal to 0, it hits that brace, it hits that brace, and it comes back around and it exits out of that method. So it comes back to where n is equal to 2, we called n equals 2, but again, n is now 0, and it comes in, it says if n is greater than 0, and it's not, it's equal to 0, so it basically hits that brace, gets out. We're done with that method. And then we come where it called the n equal to 4, again, n is equal to 0, and it comes in, it says is n greater than 0, and no, it's not, it's equal to 0. It then basically hits that brace, and we get out of that method. Okay, so that it comes back to the original calling method, message method, and it says if n is greater than 0, it's not, it's equal to 0. It basically hits that brace, and then hits that brace of the class, and basically exits the program. Okay, so again, kind of a strange beast, but it's a great way to kind of loop around and do things. But again, you have to have a way to get out of the recursive loop. And in this case, we basically have a variable n, and we're looking to make sure that it is greater than 0. Okay, so kind of a cool thing. So if we go back over here, so there's recursive demo. And again, this is kind of how it's looking. So it's calling, stair-stepping down. Yep, just like that. So the value of 5 called that method. And then we displayed, we then called it with a -1 of the n, n equals n minus 1. So now it's a 3, now it's a 2, now it's a 1, now it's a 0. But again, think of all of these previous methods. They're still open and running. They're waiting for the return of the call so that we can hit that ending brace and get out of that method. So on page 988 talks about solving problems with recursion. So what kind of problems could we have? Well, let's take a look at the example, and the example is the factorial demo. And if we take a look at the factorial demo, so here we have a public static void main, and we've got a string called input, we've got an int number, and then we're basically asking the user to enter a non-negative integer. And we go ahead and throw that into number. And then we basically have JOption pane where we say number, which is an exclamation point, is a factorial number. So first thing we do is, what is a factorial? Well, a factorial is, if I take, like, say, the number 5, it's 5 times 4 times 3 times 2 times 1. In this case, the factorial 5 is 120. If we look over here, we can see all the different factorials. The factorial of 10 is 3,628,800. Okay, so it basically goes up from there. So it's you start with that number and you multiply every number basically between that and 1. So if we look here, it's basically, and the way you display a factorial is you say the number exclamation point. That means factorial in a mathematical equation. So here we say, so here we have a method called factorial, and we're passing in an int. And we're saying if the int the integer n is equal to 0, we return 1. Else we return n times factorial, and then n minus 1. What is factorial? This is where it's calling itself. So in this case, it's calling itself. And again, notice we're always counting down. So what is going on here? So again, if we look, it says take n. So right now it's a 5, if I pass on a 5, and it multiplies it times the factorial n minus 1. So it's putting a 4 in there. Okay, so here's what I want you to think about in this case. This equation right here does not execute right away because we have to call this one first. And we call this one, and then it gets called again and again and again. So this first equation does not get executed right off the bat. Okay? But here's kind of the situation is so well, I don't want to confuse you. If we look at the method call, we can see that we've got an int. So it is returning an int. Okay? So in this case, it returns n times some number. Okay? And then it takes n times some number, n times some number, n times some number, n times some number. So what is that number? Well, this guy is going to return something. Okay? It's going to return something. Let's see if the book has a better example. Of what is going on here. So I really want you to understand this. Okay, so here we enter a 4. Oh gosh. Okay, so if we think of the stair step example, so the very first call, it's a 4. It then calls factorial with n minus 1, so it's 4 minus 1, which is a 3. So we call this one. Well, again, we aren't doing any, we are not multiplying yet, because again, we have to get out of that loop to basically do a multiply. So then we basically call the factorial again with n minus 1, which is now a 2. Which again, we turn around and call that factorial again with n minus 1, which is a 1. Then the last time we call it, it basically says n minus 1, which is now 0. And if you remember, it says if n is equal to 0, we return 1. So that's basically what's going on here. So it returns a 1. So when it comes back, it takes a 1 minus the 1, or 1 times a 1, which is a 1. It then, the next time it comes back to the number 2, and it takes 2 times 1, which is 2, which returns a 2 back to the 3, and 3 times 2 is a 6, which returns the 6 back to this guy, and 4 times 6 is equal to 24. Okay? So, again, I put a 4 in there. It then calls the factorial n minus 1, so it doesn't do the multiplication yet. It has to come all the way back to do that multiplication. So then we do the 3, we do the 2, we do the 1, we hit 0, we return 1. 1 comes back, 1 times 1 is 1. It returns a 1 to the 2, 2 times 1 is a 2. It returns the 2, 3 times 2 is a 6. It returns the 6, 6 times 4 is 24. Okay, so if we take a look at this guy, if I were to run it, it comes up, says enter a non-negative number. I'm going to enter a 5. I click OK, and it says the factorial of 5 is 120. Okay, so if we look at the book, so think of it this way. So let's say we got a box 5 up here. Okay, so up here I've got a box. and here it's got a 5. Okay, so it returns a 24 to the 5. What's 5 times 24? Well, I know 5 times 25 is 125. Well, we subtract 5 from that, it's 120. Okay, so it returns 120. If I had a 6, it would return 120 to a 6. And what's 6 times 120? Well, 6 times 2 is, so what's that, 720? So 720, it would return 720 to the number 6. Okay? And if we had a 7, well, what's 7 times 720? Well, you see how the numbers, how they get very, very large very, very quickly. Okay, so as we can see, the recursion is a great way to do factorials. So now on page 993 we have 15.3 there. It talks about using recursive methods with arrays. So now we basically have an array that has data in it and we want to do some recursion on it. So here we have what's called the range sum. So here we have the range sum, and well, let's just take a look at it. So here's the program. So here I've got range sum, public static void main. I've got an int array, and the name of the array is called numbers, and it looks like it's got 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the sum of the elements 2 through 5 is range sum numbers 2, 5. So we come down here, we can see range sum brings in the array. We've got our int start and int end, and it says if the start is greater than end, return 0, else return the array start. So again, we're passing in numbers. Again, if you don't remember, when we use arrays, in this method, it has a name tag of numbers, but in this method down here, it has a name tag of array. Same array, same grouping of numbers, but up here it's called numbers, down here it's called array. So array start, in this case, is a 2, plus range array start plus 1 and end. So we always have the end in there, but we always keep adding 1 to the start. And when the start is greater than the end, again, that's our way to get out, because we keep adding 1 to it. It basically, so again, first time I call it, so it's going to return array, whatever the starting number of the array is, plus whatever it gets returned. So again, it's going to have a whole bunch of range sums being called here. So see if the example in the book might have a nice, nah, it doesn't. So first time through, we basically have 2, because array start is 0, 1, 2. That's a 3, right? And it says range sum array, so it's got the array in there. So again, because we're expecting the array to come in, and start plus 1, which is a 3, then a 4, then a 5, then a 6, and then when it's 6 greater than 5, when that statement comes true, it returns 0. Okay, so this is returning an int. Okay, so if we basically run this, it says the sum of elements 2 through 5 is 18. So 2 plus 3 is 5, plus 4 is 7, plus 5 is, now how does that work? 2 plus 2 is 4, plus 3 is 7, plus 4 is 11, plus 5 is 16. Yeah, let's debug this guy. Now, I don't know if I ever showed you this, but we can do a right click right here in this bar and say breakpoint. Puts a little blue dot right there. Instead of clicking this circle here, I can click the little bug. And when it runs, yeah. And when it runs, it says, hey, we're going to go into debug mode. Do you want to do that? I'm going to say yes. And then it comes in and says, okay, so my start is 2, my end is 5. And if I run this guy again, start is 3 and end is 5. 4 and 5, 5 and 5. And then it basically gets out. And 4, 3, 2. Okay, so it basically... So 2 plus 3 is 5, 2 plus 4 is 7, 2 plus 5 is 12. So there's our array. I think I have it now. It basically says this. It's going to take whatever is in the starting array and add it to whatever's being basically passed back. So 2 plus 2, or 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. And then 7 plus 6 plus 3 plus 2. Is that how it's working? Okay, I've got it. So here's what it does. It goes through and it says array start, and it's got start plus 1. So it's got a 3 in there. And then it basically has 4, then 5. Then when it comes back through, it keeps adding whatever's in the starting. Well, the last time I went through, it was a 5, then a 4, then a 3, then a 2. Okay, so let me see if I can get this run debug again. Okay, so first time through, start as a 2, end as a 5. Okay, so array, which is a 2, so start plus 1 and end. So start is a 2 plus whatever it returns. And what's it going to return? Well, it's not going to return anything yet. It's because it gets called within itself. So next time it gets called, it's got a 3 in the start. Next time it gets called, it's got a 4 in the start. Next time it gets called, it's got a 5 in the start. Well, now start and end are equal. So they're basically it becomes greater than at that point. So now we're on the back side. So now we're hitting this brace at the end here. So now we're saying the start, which is a 5, and the end is a 5. 5 plus 5 is 10. 5 plus 4 . Okay, so I've rewritten it so that we can actually see what is being returned. Okay, we can see what's in X. So run this. We got start and end is 2 and 5. It calls itself again, and then now it's 3 and 5 because X plus 1. 4 plus 5, 5 plus 5. Now we're coming back. Where's the X? So X is 6. So returns a 6 because start plus, which is 5 plus 1. Okay. And then we add, it's 11 because we add 5. Now it's 15 because we add 3. It's 18 because we add 2. And then we're done. Whew, that was tough. Okay, let's take a break. We'll set this out there and we'll continue.